Kia ora Year 11 and 12. Here's another exam question from the same summer 2015 paper. This one is a trig integral one, and it's a little bit trickier, the second part, than the ones we've been doing so far. So the warm-up is the 3 marker here, which is to find 4 plus tan squared of 2x and then to integrate it. So let's see that tan squared and think about what we're going to do instead of just freaking out. Remember that I've got sine squared plus cos squared equals 1, and when I divide all of that through by cos squared, we generate one of our other integrals, which is that tan squared plus 1, tan squared of x plus 1, I can't stand not writing the x in there, I have to fix that up. Just a sec. Right, so tan squared x plus 1 is equal to sec squared x. Now we know that sec squared is really easy to integrate, and that's why whenever we see a tan squared, we're going to use this identity. Or you can do what I did in class and do it a slightly different way. But usually, if I see tan squared, I'm going to do this. Tan squared x is equal to sec squared x minus 1. So let's just park that there, and now we're going to start integrating. So we've got 4 plus tan squared 2x dx, and that works out to be 4 plus sec squared 2x minus 1 dx, which is this, so it's 3 plus sec squared 2x dx. That anti-differentiates to give me 3x plus, now this is going to go back to tan of 2x, right, but I've got the chain rule to think about in here. The derivative of the inside function is 2, but here I've got nothing, so I need to multiply this by 1/2 so that it all works out. So there we go, and a plus c on the end, don't forget that. Right, so that's the first 3 marks. Now let's look at this next bit, because it looks absolutely horrible. Right, let's make it a bit bigger. Okay, find the exact value of this integral. Well, my limits are pi on 2 and pi on 4, so that's going to be nice. I'm going to be using exact values and special triangles. This looks awful. I've got sine of x in the denominator, and I've got sine of x plus pi on 6 in the numerator. So the first thing that you might be thinking about, especially after today's lesson, if you're watching this when I've just published it, is have I got a situation where I've got the function in the denominator and the derivative of that function in the numerator? Because remember, when I saw this is kind of the first thing we hope for in a fraction, because that's going to come from this, the natural log of the absolute value of that function. Sadly, I don't have that here. But what I have got is I've got a compound angle in the numerator here. So we can easily muck around with this, expand this out, and then you can see that some of it is going to simplify with the sine x. So let's get into it and remember how our compound angles worked. Okay, so we're trying to evaluate this, the integral from pi on 2 to pi on 4 of sine x plus pi on 6 over sine x. As usual, guys, remember that you need to pause the video and have a go at this on your own before you watch me lumber my way through it. So this is pi on 2 and pi on 4, and in the numerator here I'm going to have sine x cos of pi on 6 plus the other way around, cos x sine pi on 6 divided by sine x dx. Now quickly chucking in our special triangle, what does this simplify to? Well, I've got pi on 2 and pi on 4 here. Cos of pi on 6 is root 3 on 2. And you can see that the sine x over the sine x is just 1. So that's looking good already. Plus, sine of pi on 6 is 1/2. So it's going to be 1/2. Now, this bit, cos of x over sine of x. So this looks bad, and if you immediately go and look at this and think, oh, that's cot, and that's not one of my basic trig ones that goes backwards easily, then you're going to miss the key thing here. And I've already given you a clue. So pause the video and see if you can integrate from here. Okay, so what's going on here is that I've got sine of x here, and the derivative of sine x is cos x. And there it is sitting up there. So that means that this integral simplifies as follows. I've got root 3 on 2x plus 1/2 times the natural log of sine x. I don't even have to worry about a chain rule thing on this, right? I've just got this derivative sitting nicely up here. So now we just have to carefully evaluate things. Oops. Sorry, don't know what happened there. So let's go through and substitute. Now we'll go to our round bracket. So we get root 3 on 2 times pi on 2 plus 1/2 log sine of pi on 2, which is going to be 1. So we like that. Log of 1 is going to be 0. But let's not get ahead of ourselves. So now we've got minus root 3 on 2 times pi on 4 plus 1/2 log of, well, sine of pi on 4 is 1 over root 2. So that's log of 1 over root 2 in here. But I can do quite a lot of work cleaning this up. So let's slowly work through it. We've got root 3 over 4 pi plus 1/2 log 1 minus root 3 over 8 pi. So you can see that these are going to be like terms. We're going to chuck those in together. Minus 1/2 log of 1 on root 2. Now I can clean this up as well, and I'm going to, but you don't have to, but it looks nicer. So here I've got, doing this very slowly, 2 root 3 on 8 pi minus 1 root 3 on 8 pi. So that's that done and that done. This is 0, and here I've got minus 1/2, and I'm going to split this log out like this. Log of 1 minus the log of root 2. So that equals root 3 on 8 pi. This is 0, so I get plus 1/2 log of root 2. Now, why stop there? There's even a little bit more simplification that I can do. So that's a very big tick, by the way. But I really don't like leaving logs unsorted out. So I'd like to just make sure that you can all do this, because you might need this in a different problem. So this power here means I'm going to have plus 1/4 log of 2. So that's the nicest possible answer for that question. If you look in the mark schedule, actually they were happy if you left this like this. That got a big tick. And you needed to put this and this together. Thanks for watching.